Okay, there we go. Thanks everybody for coming to this colloquium about our graduate programs in the mathematics and computer science department. So we'll jump right into it. This is just going to be an informational session. Hadi, who's the director of the CS program, and myself, who is the director of the math program, just plan to give an overview of the programs and then just have a discussion about them. So I'll let Hadi go ahead.
All right. Thank you, Dan, for the introduction. Yeah, my name is Hadi Shafei. I am the director of our graduate program, a master's in computer science. And we are very excited to start this program in the fall. And let me just start by telling you that why should someone even think about getting a master's in computer science? Because you might think that with a bachelor's in computer science, you can get a good job. So why bother staying at the school for 2 more years? And I'll tell you that there are many benefits in getting a master's in computer science. First of all, if you are thinking of staying in academia and getting a PhD, then getting a master's will be your preparation for that. If you are thinking of getting a job in industry, then there are also many benefits in having a master's degree. For example, that gives you the competitive edge that you need when you're competing for, jobs as an applicant. It also, in many companies, for jobs that requires some work experience, they consider having a master's degree a replacement for work experience. Also, when you get your master's, you become an expert in some area, say artificial intelligence or network security or something like that. And that means that when you are applying for jobs, you can apply for jobs that are in those areas, which means that jobs that are more interesting than your entry-level jobs. And in particular, if you're thinking of like leadership positions, then also having a master's can be very beneficial in that sense too. And if all of this, does not convince you, then I, have these 2 6-figure salaries that, might convince you. If you are a research scientist in computer science, then your average income will be, 122K. And similarly, for a software development engineer with a master's degree in computer science, we are looking at those numbers. So to be more precise, having a master's degree in computer science on average increases your income by 21%. So that kind of justifies staying in school for 2 more years, that jump in the salary, which is much more than the jump in like other disciplines. So that's another very good reason to get a master's in computer science. And the job outlook for CS looks excellent at the moment. So 15% increase in the job market until at least 2028, which is very promising for people who are in this area and they're intend to look for jobs in the near future. So that's like an overall motivation of why should we think about getting a master's in computer science. Now let me dive into our own program and tell you a little bit about our program that we are going to start in fall 2021. So we have 2 possibilities for our students. When we were designing this master's program, one of the main things that I had in mind was flexibility. So we have 2 paths that the student can take. We call them plan A or plan B, or you can call that thesis or project-based. The big difference between the 2 is that for plan A, you have to write a thesis at the end and defend it. And that means that it's more research-oriented, it's more focused on research. But plan B is more suitable for people who want to get their master's and then get a job in industry. So it's project-based. So instead of a thesis, you do a project at the end, which will be something similar to the senior project that we have for our undergrads, of course, to a greater extent. But that's the big difference. Overall, both of them require 32 credits of coursework. For plan A, 8 of that will be research and thesis. For Plan B, 4 credit will be for project. The rest of it will be coursework. And for the coursework, we have 2 courses that are required for both Plan A and Plan B. Advanced algorithm design, that's one of the core courses in like any computer science program, any graduate computer science program. And also a seminar in computer science, which gives you many useful skills, whether you want to stay in academia or you want to go to industry. Skills like, you know, presenting your results or writing scientific manuscripts and things like that will be discussed in this course. And besides these 2, we have 5 categories that the students pick 3 out of 5 from those categories, and they have to take 1 course from each one of those 3 categories that they chose. And we call these the breadth requirements. And here are the 5 categories. So we have software, networking, AI, theory, and programming languages. And as I said, both for Plan A and Plan B students, they pick 3 out of 5 and take 1 course from each category that they chose. And we have, you know, faculties who are experts in, you know, these areas. For example, I will be the person who teaches the theory courses for the most part, and some of the programming language courses like functional programming, or if we offer a course related to interactive theorem proving and things like that, that falls under this category, and that would be my area of expertise. And we have, as I said, very excellent faculty members who are experts in other areas like AI and networking and software engineering, and they will be teaching courses in those categories. So 3 out of 5 for the breadth requirement. And for the research core courses, for Plan A students, for students who intend to, you know, mostly to stay in academia, maybe get a PhD after the master's degree, they have to do more in terms of research. So they take 2 courses, research in computer science and thesis in computer science, and they write a thesis and they defend it. And for students who want to get their master's degree and then move to industry and get a job at a company, then for the research core, they take the project in computer science course and they do a project at the end of their program. After all of these, for Plan A students, 8 credits still left. And for Plan B students, 12 credits left. And they can, you know, take elective courses. These elective courses can be graduate CS courses from, you know, the breadth requirement or other special topics courses that's, you know, we may offer. Or they can take other graduate courses with the approval of their advisor. For example, taking like a graduate mathematics course that is relevant to their research would be one option that, you know, can fill the electives. So overall, as I said, 32 credits. It takes 4 semesters normally. And we have directed study courses and things like that that I didn't, for the sake of time, didn't include in this presentation. But as I said, it's a very flexible. You can get to choose the courses that you like, and you want to become an expert in that area with the 3 out of 5 breadth requirement and things like that. I think that's the end of the presentation. As I said, we are very excited and we are accepting applications. Let me know if you have any questions.
Yeah, I think we should discuss the computer science program for a little bit. I will talk about the master's in mathematics, but with the way this is set up, I think it makes sense for if anyone has any questions for Hadi about the.
Yeah, I'll be happy to answer any questions. Yes.
I have a question, I guess.
Yes.
Oh, hey,
so, yeah, hello, it's me again. So I'm assuming all of these courses are in person, right? None of these are virtually.
So for at least for the next semester, there will be, the plan at the moment is that the courses that we are offering in the fall will be in person, yes. But we have to see how things go until then. But yes, our plan is for fall 2021, the graduate courses that we offer are going to be in person. Yes.
All right, thank you.
You're welcome.
Maybe I'll jump in there just in terms of flexibility. Because of the pandemic, some of us are set up for some sort of hybrid model. And Hadi, I don't know if the CS committee was considering, even though the classes will be offered face-to-face in the fall at NMU, it looks like at this moment anyway. Would there be potentialities for the classes to have this hybrid format where a student could take a lot of the subject matter remotely or through Zoom? I don't know.
Definitely, yes. Yeah, if needed, definitely we can go with the hybrid format that we are doing this semester. Yes, so if there is a need for it, definitely we can make the in-person into hybrid, so that the students who don't want to be on campus, they can take the courses online. Definitely, yes.
Hey, Hadi and Dan, I have a quick question. So this seems to break out to like 2 courses a semester. Does that seem about right?
Yes. Yes. So 8 credits per semester. That's the normal load for a master's program. Yes.
And would these classes be like during, like after, like 5, like after work hours?
Not all of them necessarily. Again, it depends on the needs of the students, but at the moment, no, this is not like a program that will be only in the evening. But yes, if needed, we can offer some courses in the evening too. But probably not all of the courses, no.
Yeah, the same goes for, I guess, our Masters in Mathematics program. We don't really have the flexibility at this moment to offer a schedule where they're after hours, after work hours, like in the evenings and stuff like that. I think both of these programs are, at this moment, incepted to just be kind of traditional time slots during the day. That does make me think of one thing, Casey, which is with the hybrid models that we're all using because of the pandemic, this might be very difficult to do in a master's class, but because there are potentially lecture recordings, a student could watch the recordings and participate in the class asynchronously. That's not something I've really thought about yet, and I haven't done that for a master's student, but I wonder, and I don't know if you would agree with me, Hadi, that is potential or somewhat potential for that.
It is a possibility. Again, just like you, we haven't thought about it, but we can give it a thought and see if we can make that work too. Yes, it's definitely a possibility. Yes.
Sweet, thank you. Yeah, I was just thinking about the kids that, like myself, that go and get jobs after they get their bachelor's, and then they want to come back for their master's, and it might be, I mean, I can work it out, but I'm like, for other people, it might be a little difficult.
No, it's a good point, Casey,
Yes.
for sure.
I had a question. Is there anything we can do maybe over the summer to get some credits done for it or something like that?
Yeah, so definitely we have the potential for that. An easier option would be doing a directed study with a professor. So you find someone, and then who find a professor who is interested in teaching during the summer, and then you can have a directed study with them that can count towards one of your breadth requirements, for example. So yes, it's possible. At the moment, we don't have a plan on offering a course this summer because we are starting the program in the fall. But if needed, definitely, it can be a directed study, which will be a replacement for any requirement, your electives or your breadth requirements, or even the core courses. Yes, so that is a possibility, and that can boost up, in stuff like 2 years, maybe you can finish in like a year and a half or something like that, if someone wants to do that. Yeah.
Another point on that, Xavier, would be, I mean, it's never too early to start your research work, your project in a master's program. So if you were serious about the program and had a project in mind, as long as you were communicative with the professors in the program about the legitimacy of the project as a master's thesis, you could begin working on it this summer. Maybe that's a little bit difficult given that you haven't done the coursework yet, but not all the time is the research work exactly correlated to the coursework. So that's another option. I don't know. What do you think, Hadi?
Yeah, that's a very good point. Yes, absolutely. So at least you can get an idea of, the kind of things that you want to work on for your research, and at least start maybe. Yeah, so that's definitely another option for doing some work during the summer. Yes.
Great questions. Anything else for CS? Okay, we'll bring it back to a general discussion afterwards. I'm just going to do my little blurb about the Masters in Mathematics program. And these two programs are supposed to be synthetic with each other. The computer science program, I think there is some credits available. You were mentioning to take a 500 level mathematics class in the program that I'm about to describe, so that there could be some synthetic stuff going on. In our program, we have a class called Topics and Foundations, which is the foundations of, can be broadly understood as the foundations of mathematics and computer science. So there's a potential overlap in that regard as well. So let me jump into a description of this program here and make sure everyone can see it okay. So I'm sharing my slides. Can everyone see that okay? Okay. Okay, so this program was created in 2000. We started in fall 2019, so it's had basically by this April, it'll have been running for 2 academic years, and we'll have our first group of graduating students. We have 5 students graduating this April and May, so we're very excited about that. Why can't I? Well, there we go. So I'll start just like Hadi did. Why would you consider this? Well, perhaps mathematics can't necessarily boast the 6-figure salaries to the degree that computer science can. But nonetheless, obtaining a master's degree does give you a leg up in any applicant pool, in any job search that you're engaged in. It's an intellectually stimulating environment where you can work on some stuff in mathematics. One particular track that many students are interested in is moving up through these professional actuarial exams. So if you have an interest in actuarial science, working in the insurance industry, there are these difficult exams. And this master's program gives a mechanism for a student to do that. It gives you a stimulating environment where you can research some advanced mathematical topics and compose a thesis. You can prepare for PhD programs in mathematics if that's of interest to you. Obtaining a master's will give you qualification to teach college level mathematics. And there's financial support options available. So there are scholarships offered internally by NMU. There's also external scholarships that you can always apply for to support your graduate work, whether it's NSF or other organizations. There's also an opportunity to apply to teach a 100 level mathematics class like pre-calculus or college algebra at Northern. So you can gain experience teaching a section of 100 level mathematics, which pays a stipend. And so that's a way to gain some financial support when you're in this program. Also, Marquette is a beautiful place to live and work. So of course I have to mention that. Okay, so this is a description of the program itself in terms of credits. So there's 32 credits, just like the Masters in CS. There's 3 4-credit core classes. Advanced linear algebra is one of them. Linear algebra is a fundamental mathematical topic. So when designing the program, it made sense to include a core class on linear algebra. This is a little bit different than certain programs you see. There's real analysis and complex analysis are 2 areas of mathematics that generally are taught separately. But I think that the theorems in the principles and theorems in the 2 subject disciplines are close enough to each other that even though they're traditionally taught separately, I think it's quite helpful and interesting to sort of handle them both in one class. So we have real and complex analysis as one of our cores, and then topology, which is, I'm teaching it right now. It's a lot of fun. It's a wonderful synthetic interplay between algebra and space. Topos is Greek for space, and obviously logos is the study of, so topology is literally the study of space. Why is a donut different than a sphere? Why is that different than a donut with 2 holes? The mathematics of space is essentially topology and can be very interesting. So there's room for elective classes within this program. You need to choose 3 of these possible ones. So they're relatively flexible depending on the faculty member's expertise and interest who's teaching it. So there's topics in algebra. This could cover, depending on the faculty member's interests, things like ring theory, Galois theory, representation theory. So Lie groups and Lie algebras, or algebraic geometry. There's a lot of potential for what this can cover. Topics in geometry, which would be more advanced topics in geometry. So non-Euclidean geometric ideas, curvature, Riemannian geometry, subject matter like this. Could be possibly covering spaces in the fundamental group, which is a nice correspondence. Topics in analysis, which lets you go further in analysis, things like non-smooth analysis or functional analysis, once again, depending on the faculty member. This is the class that could lean towards computer science, depending on who's teaching it. The foundations of mathematics and computer science are incredibly related. So this could be about something depending on once again, depending, it could be about category theory, or it could be about type theory, or it could be about mathematical logic and the foundations of mathematics. This class is interesting in its own right. This would cover financial concepts, options and derivatives and how to price those options, Brownian motion, stochastic processes. This is more geared a bit towards students interested in actuarial science and studying for those exams, but it is mathematically interesting in its own right. And a graduate class in probability. Okay, so you would choose 3 out of these 6. I mean, there's also special topics which can vary, but you need to produce 3 of those. Then there's the research core, which is 8 credits. You basically spend 4 credits preparing a project and doing research on a thesis, and then 4 credits writing it up and finalizing it at the very end. And there's 3 streams in this program. There's the traditional thesis option, which is a student engages in research and scholarly work it culminates in a publishable manuscript that's defended to a 3-person committee at an oral defense. There's also the possibility for a project. Now, the idea here is not necessarily a traditional academic thesis, but some sort of interdisciplinary project. And this gives some flexibility for a student who's interested maybe in mathematical computer science or mathematical biology, where the final outcome is some tangible project, but it isn't necessarily a publishable thesis or a publishable manuscript. But there's still an oral defense where you have to go in front of your committee to justify and explain the project that you've done. Now, the students interested in actuarial science, this program gives a nice container for them to study and be mentored while they study for and look to pass 2 professional actuarial exams that they haven't already passed. So for example, this could be like the Society of Actuaries or the Casualty Actuarial Society's exams P and FM. P stands for probability and FM stands for financial mathematics. which the two elective classes in our program are designed to kind of focus on. So just to review again, why would you want to do a master's in mathematics? It's an intellectually stimulating environment where you can study for these actuarial exams or perform research in advanced math and write a thesis, prepare for a PhD. The qualifying exams of PhD programs involve the mathematics of topology, linear algebra, abstract algebra, and the classes in our program help a student to prepare for success in PhD programs around the country. And it gives you qualification to teach at the college level. And there's financial support available. And Marquette's, once again, Marquette's a beautiful place to live and to work. This is the link. You can just search NMU Graduate Mathematics. It takes you to an Apply Now link where you can fill out your information, and that's how to begin the process of it, the application process. So our program requires just transcripts from undergraduate institutions you've attended, all relevant transcripts, and 2 letters of reference. Okay, that's everything. So thanks for listening. So I'm open to questions now if you have about the program. Otherwise, we'll just switch back to kind of a general discussion. +1 for remote study in CS. I'm not local to the area. Yeah, Jim, that's a good point. I think Hadi was mentioning that such potentialities could exist. And it's sort of because of the pandemic that we've all started to explore these options. But I don't know if we can give a definitive answer that yes, it can be done completely remotely at this moment, but that is definitely on the docket. So does it make sense? Does anyone have any questions for us? Jim, you're not local to the area. Where are you tuning in from? I'm just curious. Maybe you didn't hear me or something. Well, anyway, if anyone does have any further questions about these programs, there's information on the website, the department website. I can briefly share that link for everyone. It probably is well known to everyone, but let me do that here. The Mathematics and Computer Science website here under the degree programs, there's this graduate programs link. So I'll put that in the chat. Okay. Are you sure there's no more? Are you sure there isn't any questions?
Hi, this is Mike Kinnan. I might have a question here.
Yeah, please go ahead.
And I might have just missed this from earlier, but on the graduate studies website, it says the CS Masters has a deadline of March 1st for applying. Is that still a thing, or?
I don't know if that's accurate. I wonder how that got in there. Hadi, can you speak to that?
Yeah, no, we are still accepting applications. So if you're interested, contact me. I can give you more information. And by the way, yes, let me just put it out there that if anyone has any questions about, the CS graduate program, feel free to contact me. My email is on the department's webpage, and I will be happy to answer your questions. And for the deadline, no, definitely we are still accepting applications. So yeah.
Mike, where did you see the March 1st thing?
It was on the graduate studies website.
Huh. Was that mentioning CS specifically, or just was it just sort of a general blanket statement?
No, it was CS specifically. There's like an accordion menu with each major separated out, and under CS it had March 1st deadline.
We should drop an email to grad studies, Hadi, just so that they're aware of that.
I'll contact them and make sure that.
I can change it for you right now if you want me to.
You can change the website.
Yeah, I work at NMU. I'm part of the staff.
Oh, okay. That's kind of funny that you actually have the power to change that directly. That's great.
Did you just want me to just get rid of that line, or
Yes,
change
please.
it to something else?
And how often does that happen in life, that the person who has the power to make the change is immediately in the conversation of interest? That is very convenient. Okay, well, I think I will go ahead and just end the recording here. Thanks everybody who are listening, either in real time or in non-real time, watching this recording later. So yes, thanks.